Now we'll be looking into the changes that take place during the formation of an ionic bond. The formation of ionic compound AB in the solid form from the gaseous atoms say A and B can be considered as follows. A in the gaseous form is combining with atom B in the gaseous state, leading to the formation of compound BAB in the solid form. The formation of ionic compound from the gaseous atoms is considered to be taking place in 3 steps. The very first step is formation of gaseous cation. Suppose atom A in the gaseous state is leading to the formation of cation A plus in the gaseous state by the release of an electron. This process is endothermic in nature. That means heat is absorbed during the process, and this absorbed heat can be denoted with the help of positive sign. Suppose the heat absorbed is x kilojoule per mole. This amount of energy which is being absorbed is known as ionization enthalpy. Next, let us consider the atom B. The formation of gaseous anion from B takes place as follows. B in the gaseous state is accepting an electron to get converted to the anionic form, that is B negative. The following process takes place by the release of energy which is known as electron gain enthalpy. And this energy is shown by minus Y. Negative sign indicates the energy which is being released. The third step is packing of these ions, that is the cation and the anion which is formed in the first and second step, to form a solid compound AB. The reaction could be considered as follows. This overall process should be exothermic. This third process is also exothermic in nature. That means energy is released during this process. And since the energy is released, the molecule formed is found to be in a stable state. The heat energy change taking place during this third process could again be considered to be negative. The energy or the heat which is released in the third process is known as lattice enthalpy. Now what is lattice enthalpy? It is the amount of energy released when 1 mole of ionic solid is formed by close packing of gaseous ions of opposite charges. This lattice enthalpy or the lattice energy is also dependent upon various factors, like it depends upon the size of the ions. If the size of the ion is smaller, the negative amount of lattice energy becomes higher. That is, smaller the size, of the ion, more is the negative value of lattice enthalpy. For example, for NaCl molecule, this energy is minus 769.8 kilojoules, while for KCl, this energy is minus 698.7 kilojoules. It is indicating that smaller is the size of the ion, more is the amount of lattice energy. And the negative sign here is indicating the amount of energy, is indicating the energy that is being released during the process. The next factor upon which this lattice energy depends is the charge on the ions. More is the charge on the ions, greater will be the force of attraction and more stable will be the molecule, and therefore higher will be the negative value of lattice energy. More charge indicates more negative value of lattice enthalpy or lattice energy. Now what is the use of this lattice energy? With the help of this lattice energy, we can take an idea about the intra-ionic attraction, then we can also know about the stability of the ionic compounds. There are certain conditions for the stable ionic bonding. Let us have a look of these conditions. Conditions for stable ionic bonding. Now if we just talk about the energy changes, the changes which are taking place during the process, we'll come to know that three types of energies are involved during this process. First one is IE, that is the ionization enthalpy. Next is electron gain enthalpy, and last one is lattice energy. How these energies affect the stability of the ionic bonding, we should have a look of this thing now. Let us first talk about the ionization enthalpy. If the value of ionization enthalpy is lower, the stability of ionic bond will be higher. Ionization enthalpy should be low for a stable ionic bonding. Next, we talk about the electron gain enthalpy. The negative value of this should be more. Similarly, if we talk about the lattice enthalpy or the lattice energy, again the negative value of it should be more for a stable ionic bonding. Now next is the general properties of ionic compounds. The very first property is the physical state of the ionic compounds. Ionic compounds usually occur in the crystalline form, where the ions are arranged in a well-defined geometric pattern to constitute the ionic crystal. Let us take an example here to understand about the physical state. The example of NaCl we can take. If we study the structure of NaCl, we'll come to know that here 6 Na ions are surrounded by 6 chloride ions, and 6 fluoride ions are further surrounded by 6 sodium ions, giving this structure, the molecule, a well-defined geometry. Next factor is, or the next property we can say, is melting point and boiling point. Since the ionic compounds have strong electrostatic forces of attraction, therefore large amount of energy is required to break the forces of attraction from among them. And that is why they possess high melting point and high boiling point. Next property is the electrical conductivity. Ionic compounds are found to be good conductors of electricity, but in molten or dissolved state, since in these states the ions become free to move. That means these compounds are bad conductor of electricity in their solid state. Next is the solubility. If we talk about the solubility of ionic compounds, we'll come to know that they are soluble in polar solvents like water. And they are insoluble in non-polar solvents. Next is the type of reactions. The reactions involve combination between ions formed in their aqueous solutions. Example, AgNO3 in aqueous form combining with NaCl in aqueous form, leading to the formation of products AgCl and NaNO3. Such reactions take place instantaneously. This is all about the ionic bonds. Now next we'll move on to the topic of covalent bond. In the ionic bond we have seen that it is an interaction between the ions of opposite charges. Now what happens in the covalent bond? It is a force which binds the atoms of same or different elements together by mutual sharing of electrons. There is no transfer of electrons from one atom to another in this type of bond. It is the mutual sharing of electrons, and the sharing can take place between the atoms of same or different elements. We can understand it in a better way by taking the example of fluorine molecule, that is Cl2 molecule. Let us see the electronic configuration of fluorine. We all know that atomic number of fluorine is 17. That means it has 17 electrons in its shells. So the configuration would be 2, 8 and 7. Now to complete its octet, fluorine needs 1 electron, which could be, to complete its octet, fluorine needs 1 electron. Let's see the Lewis structure of fluorine. The valence shell electrons can be seen as dots here. Now, if we talk about two chlorine atoms in vicinity of each other, we'll come to know that second chlorine molecule also possess same number of electrons, and thus they can undergo a sharing of electrons. Through this sharing of electrons, they both complete their octets. Now for this chlorine, the octet has been completed, and similarly for this chlorine, the octet has been completed. And such a bond formed among these two atoms is known as covalent bond. The covalent bond is shown by small line among the atoms. And rest of the electrons which are present on chlorine, those which were not taking participation in this bond formation, they are termed as the lone pair of electrons or the non-bonding electrons. The electrons taking participation are the bonding electrons. Let us see one more example for covalent bond. Say for oxygen molecule. In case of oxygen, let us see the configuration first of all. For oxygen, the configuration is, since the atomic number is 8, configuration would be 2, 6. That means oxygen is having 6 valence electrons. Now when two oxygen atoms come close to each other, they try to complete their octet by the sharing of electrons, and this time 4 electrons are taking participation in the bond formation. That means two covalent bonds are formed. From this example we have seen that covalent bond could be a single covalent bond or it could be double covalent bond. So next if we see the example of nitrogen molecule, we'll come to know that nitrogen in the similar way forms triple covalent bond. From this we'll come to know that the covalent bonds are of three types. That is single covalent bond, we have double covalent bond and triple covalent bond. Next is the properties of covalent bonds. First is physical state. The covalent compounds generally exist as individual molecules. Unlike ionic compounds, which are solid in nature, mostly covalent compounds are liquids or gases. Some solid covalent compounds are urea, sugar, non-conductor of electricity. The covalent compounds do not conduct electricity, and this is due to the absence of or the unavailability of the ions. In fused as well as dissolved state. That means covalent compounds do not possess ions in fused and dissolved state, so they are not able to conduct electricity. Next we'll look into the property of solubility. They are insoluble in polar solvents while soluble in non-polar solvents. The last property is molecular reactions. Covalent compounds undergo molecular reactions which are generally slow in nature, and such reactions involve breaking and formation of new covalent bonds. We can understand it with the help of an example of formation of HCl from the molecules of hydrogen and chlorine. Here we see that the covalent bond between hydrogen and that between chlorine and chlorine undergoes dissociation and a new covalent bond is formed between hydrogen and chlorine. This is the example of molecular reaction. Now we move on to next type of bond, that is coordinate bond. It is also known as dative bond. This type of bond also involves mutual sharing of electrons. Then what is the difference in these two types of bonds, that is coordinate bond and covalent bond? The actual difference lies in the fact that in coordinate bond, only one atom takes participation in donating the electron. It is the mutual sharing of electrons between two atoms, but the shared pair of electron is contributed only by one of the two atoms. Suppose if A and B are undergoing the coordinate bond formation, then the electron pair would be completely donated by one of the atoms, say A, to another atom, that is B. This type of bond is shown with the help of the arrow sign, directing from the donor atom to the acceptor atom. We can take an example to understand this bond. Let us take the example of ozone molecule O3. Oxygen. The configuration is again 2,6. Lewis structure is. Now the formation of O2 we have already seen during the covalent bond formation. Let us have a look of that once again. Oxygen, one of the atom is combining with second atom of oxygen, leading to the formation of two covalent bonds and hence completing their octet. But if one more oxygen is present in the surrounding, the oxygen molecule can combine with it to lead to the formation of ozone molecule. And during such a condition, one of the electron pair is completely donated by one of the atoms. In this case, it is being donated by oxygen labeled as B. The bond could be shown in this form. It could be shown in this form according to the symmetry. We can see some more of the examples for coordinate bond, like for SO2 molecule. S combining with oxygen through covalent bond and further donating its electron pair to another oxygen, leading to the formation of coordinate bond. Similarly for HNO3, we can see the bond formation. Nitrogen having lone pair electrons undergo covalent bond formation with oxygen atoms, and further donating its electron pair to one of the oxygen atom like this, hence leading to the formation of the molecule. So this is all about the coordinate bond. Formal charge. Formal charge is difference between the number of valence electrons